In the previous video, we looked at these two sets of parametric equations and noticed that the graphs of the two looked like they were the same parabola. This one was tracing the parabola from left to right, and this one was tracing it from right to left, going a little bit slower on this one. To see that they actually are the same parabola, we do a process called eliminating the parameter. I'm going to take these set of two equations where x and y are both dependent variables and t is the independent variable, and we're going to make them into one equation that doesn't have the t in it anymore, just x's and y's. So we're going to get rid of the t. We're going to eliminate the parameter. Right? Sounds like we're going to do a hit job or something. And there are several ways that this is done, and over the course of a few videos here we'll run into a few possibilities. The first way is a simple substitution, in that find one of the equations, either one, in this case it happens to be the x one, where it's easy to solve for t. So I'm going to just say t equals, I can divide both sides by 2 here, x divided by 2. Right? Once you've done that, you take that and plug it in for t in the other equation. So I've got y equals 1 minus, now the t is x divided by 2, and I need t squared. Okay, so right there I have eliminated the parameter. I'm going to multiply this out a little bit here just to make it look a little different. So I've got y equals 1 minus x squared over 4. Now, I'm much more used to looking at, well, I should say you're probably more used to looking at equations like this because we've never really done them before with parameters in them. So this is just a function, y is a function of x, and you might have some idea what the graph of this looks like. I mean, it's got an x squared in it, so it's probably a parabola. The divided by 4 squashes it in the y direction by a factor of 4, and the minus sign flips it upside down, and the 1 shifts it up 1. So this looks to me like a parabola. It's got a y-intercept of 1, and it opens downward. Right? Well, that's what we saw. That's what we got. Some people think of this eliminating the parameter as a way to draw the graph. That is, they say, oh, let me just eliminate the parameter, see what it looks like in terms of y and x. It's like, well, sometimes that works. To me, though, that's like saying, hey, I'm learning a new language. Let me translate back to my old language and not think in the new language. Yeah, maybe get you by to start with, but if you really want to be fluent, you want to be able to think in the new language. So this is a tool for us, but let's not make it a crutch. Let's try this one. Let's eliminate the parameter here. Again, it's easier to solve for t in this first equation than it is for the second one. So that's what I'm going to do. I'm going to multiply both sides by -1 here. So I've got minus x equals t. And then I'm going to take that and plug it in for t right there. So I've got y equals 1 minus, now t is equal to -x, and I need that squared, and then I've got that whole thing divided by 4. Well, -x squared is the same as x squared, so I've got y equals 1 minus x squared over 4, and what I see is this equation that I ended up with is the same as the equation that I had over there. So both of these parametrizations, both of these sets of parametric equations describe the same parabola, but as we saw, they describe it in different ways. They describe motion along it in opposite directions at different speeds. Okay? But yet we can see we are tracing out the same parabola. Right? How much time? I got lots of time. Let's throw into this video as well another technique. When you're dealing with functions like this that are polynomial or whatnot, particularly if you've got one of the functions being just linear, the way to eliminate the parameter, the easiest way is just to solve for t, plug it into the other one. You've gotten rid of the parameter, and now you've got an equation in x's and y's. Okay. In the event that you've got some trig functions, there's another technique that we use quite often that I want to show you here. Let's just look at x equals cosine t, y equals sine t. And actually, as I'm writing this down, I'm thinking, you know what? They actually have seen parametric equations before. They just didn't know it. because when I see these two things, all of a sudden I'm feeling like, wow, what if I think of t as an angle, rather than thinking of t as time, think of t as an angle right here, give this hypotenuse 1, and then this side over here is the sine of t, and this over here is the cosine of t. And so if I think in terms of setting this on a coordinate system here with t in standard position, then the coordinates of this point, the x-coordinate and y-coordinate, are determined by those two functions, where t is the parameter. Now, we probably called it theta before, but we've done this. What is the curve that we get for all the different values of t? That is, t goes from 0 or from minus infinity to plus infinity. Well, what's happening is you're going to be getting a bunch of points that all happen to lie on a circle of radius 1 centered at the origin for different values of t, and you're describing the unit circle. Okay. Now, you may look at that, and if I say eliminate the parameter, you might say, well, I can come up with an equation for the circle centered at the origin of radius 1, right? That's x squared plus y squared equals 1. Well, let's see how we might get that. I got two ways to get that. The easiest way is to say, oh man, let me take sine and cosine kind of go together, but sine squared and cosine squared really go together. So I'm going to take this first equation and square both sides. So I've got x squared equals cos squared theta. T. And likewise, I'm going to take this one and square both sides. So I've got y squared equals sine squared t. And now what I'm going to do is I'm just going to add them together. So the left-hand sides add up to x squared plus y squared. And that should equal the sum of the right-hand sides, which is cos squared t plus sine squared t. And I've been very clever because cos squared t plus sine squared t is equal to 1. And the parameter was just eliminated. I now have x squared plus y squared equals 1. Right? So there you go. There's a different technique. Also an introduction to using parametric equations to draw circles. And we will do a lot with drawing circles and ellipses and stuff here over the next week. Anyway, eliminate the parameter.